I didn't waste an hour. Okay. So this was quite a stroll down memory lane for the last class because I'm going to ask you a bunch of questions that we have learned several times this year, and many of you are going to make some uncomfortable faces as I ask you to tell me what we're going to do here. Okay? So be aware, be afraid, be very afraid. Okay. Now we're going to be talking about, I guess let's go to the title. We're going to be talking about two things, radicals. Hopefully you remember what a radical is. That is anything like, square root x, x to the 1/3, x to the 1/2. Those are radicals. And rational functions, 1 over x or x over x squared or anything like that. Okay? We're going to be just looking at those because these have very unique implications, unique characteristics for calculus. Now, this is a pre-calculus course, and it's never been really called that until the new curriculum. It was always 30 pure. Well, 30-1 is called pre-calculus. So this one actually lends to calculus much more than 30 pure did. The other thing that a lot of people who take Math 30 do end up taking calculus sooner or later, okay? Either in high school or in university. If you're going to go into anything that says science at the beginning of it, you will be taking a calculus course. You cannot get around it. Even if you take business at U of A, you've got to take calculus. Okay? So, even that you get in the arts way, right? But then that's business. You need to take your calculus course because this course really takes you to another level. Trust me. The first year calculus, no, the second calculus course is the highest dropout rate in U of A. It's a tough one, a lot of work. Okay, I'm saying that anyone that's passed 30 pure could do it, but it is so much work that it would, it's hard for a first year student to do that much work. That's the hard part because you don't really grow up till after first year university. Like you're just there for a good time, not a long time, right? And then you're like, well, and then second year university, you actually go, well, I got to decide, like, am I staying or am I going? Because if I'm going, go. But if you're staying, now you got to, really commit, right? So it's a hard course for first year students. Now, let's just look at the square root x, okay? Now, if we had x and we put -4 into there, what would you get if you put -4 into here? Square root of -4 is? Can you do it? No. So this is undefined, right? Square root of -1, same thing. Square root of 0, 0, okay? So be aware that when you take the square root, square root of 1 is 1, okay? Now, everybody should know the answer to this, but what are these called? Points that do not change are called, oh, I heard it that time, invariant. Okay? You remember that? Now, square root of 4 is 2. So you got 4, 2. Square root of 9 is 3. So you've got 9, 3. Square root of 16 is 4. So you got 16, 4. So this is what a square root x graph looks like. Okay? Now, because I know all of you know this stuff, and because I told you domain and range, domain and range, domain and range, that's what you're going to get asked over and over and over again. You got to know them well. Okay? So, domain, Brianna. Just look at it. Tell me the domain of that. See, that's the face I'm talking about right there. No problem. What x values are represented by that graph? Well, are these x values on the graph? No. Well, all of these, right? So how would you define all of these? Here's one right here. Then aren't these points on it? Okay, you're off the hook. Now I need range. Andrew? Good. Okay. Now, you may have seen this stuff in your travels. Okay. So you had a little break from it for a week and a half. Now we're back at it. Okay. Like I said, the great thing about this, if you know it, you still get it kind of reminded. It's not like we did it first unit and then we haven't touched it. And if you don't know it, it haunts you. Okay? So we're going to do a couple questions. Now, we started with y equals square root x. That's what we started with. So let's do all the replacements and tell me what happened. I'm just going to wait for about 5-10 seconds, get everybody nervous, and then I'm going to pick your name. Alyssa. Okay, translate that for me. Mm-hmm. Left. Okay, so let's go up 4, 1, 1, 2, 3, 4, and we'll go left 2, 1, 2, so we're going to be about there, right? So that's what your graph should look like. Okay, so we're not going to do all of these. Let's do D next. And I will get Alex to help me with this one. Okay, can we rewrite this maybe first? Okay. Yep, so tell me what to write down. I'll write it. Can you tell me what to do? What would get you the mark on an exam? That's what you want to do. Okay. Hopefully you all remember that little nugget, because something like that, you better not screw up on an exam. That would be on your study sheet, right? I hope. Okay, talk to me. Replacements. No? Gonna do stretches before you do translations. Okay, so now I'm going to pick somebody else to help me translate this into English. Jamie Priddens. Okay, so a vertical stretch by 3 would take this thing and have it looking like this maybe. Maybe even more. And then a horizontal stretch by a half. Do you get that that's going to squish? I'm not going to pull that out. So it's even going to look like more like this. Okay, it's even going to get steeper because if you squish it this way, right? And then I am going to move 1/2 units to the right. So this would kind of be my final graph. Now be honest, you missed this stuff, right? It's good to get it back. Okay, next. Now these are always good because they're domain arranged, and you have to actually know your stuff, or these are quite interesting. Now, let's rewrite this first. How could we rewrite this correctly? Put the a on the other side. So that'd be 1 over a y equals square root b of x. So you should see that b is definitely with the x, and the a is definitely with the y. Now, what would be the domain and range if a is greater than 0, b is greater than 0? Now, you have to know that y equals ab of x, just the normal graph, looks like this. Right? That's your normal graph. Now, if a is greater than 0 and b is greater than 0, what does that mean? Positive. Yeah, it means a is positive and b is positive. So if here's your graph, and a is positive and b is positive, how will it change that graph? Since they're both positive, will they stay in that quadrant? Yes. Okay. So, Luke, domain and range. Okay, the next one. Now, what I always do, because I'm very visual, I will draw my original. A is less than 0, B is greater than 0. So that means A is negative, B is positive. What quadrant would that graph end up in, Colton? 2? What is, when A is negative, what is that? When A is negative, which transformation is that? On the, no, look right here. If this is negative, this would be a reflection on the x. Okay? Domain and range. Talk about my x's first. Here's all the x values, right? And y? Good. Question. Or to solve it for you. Okay. Next one. A is greater than 0, B is less than 0. That's positive, negative. Okay. Remember what the original looked like. Warren, where would that one be? It should be, right? Okay, so domain. Good. Last one. Stephanie? They're both negative. Here's my, where would it go? Good, because no matter where you do it, that's a reflection on the x, then a reflection on the y, or you could do it's a reflection on the y, then a reflection on the x. No matter what, you're ending up there. Okay? Domain and range. Okay, so we're doing 1, 2, A, C, and 3 to 5. Lesson 2. Well, that wouldn't be very much fun. Okay, now we're really getting into the pre-calculus stuff, okay? Now, we're going to do some square roots of graphs, but I need you to understand a bunch of rules. So there's more rules you need to know, okay? When you graph y equals f of x, there are rules, or square root f of x. Now, what I want to do is I want to start with number 2. What I want you to do, in y1, can you just put x cubed? And in y2, I want the square root of x cubed. And make that the dark line. Okay, if you need to see what's going on, look up. And also, I need these window settings. Negative 221, negative 221. Okay. Now, so we have that. And we have that. Therefore, we should all have that. Now, this, you can see right down here. And this is the graph of square root of this. Now, there is tons of stuff in here that you're going to be just given graphs without the equations, and it'll say, draw the square root of it. So we got to use some evidence here of what's going on. Now, this point is what? What's the y value right there? 0. What do you think this one is? 1. Do you see that these are both shared by both of them? Y? What's the word I'm looking for? They're invariant. Now, what's really weird, though, I want you to see this part. You see how this is the original graph? If you take the square root of it, the graph goes on top of it. And then over here, the graph goes underneath it. Just so you know, this is the new one, right? We nice to have a color one of these, but this part here, it's kind of like a little bit of a head scratcher, right? Why is the taking the square root of something give you, like, why does that graph come above? Now, just get out of here quick. So second quit. All I want you to do is go the square root of a half. Square root of 0.5. What do we get? Did you know that anytime you take the square root of anything between 0 and 1, aka a decimal, it always gives a larger answer? Because 0.71 times 0.71 is 0.5. Okay? Because when you multiply decimals it actually gives a smaller answer. Right? And we're not thinking of multiplying much as giving a smaller answer, but if you take a half times a half, you get a quarter. Right? So that's something that is quite valuable to know, is that between this invariant point and this invariant point, all the now this is between 1 and 0. So this is kind of like what I'm going to call the red zone today, okay? And hopefully you've got a red pen and a ruler you bring into your diploma, but you're always going to do the red zone on these because the red zone is a pretty important spot. Because in the red zone, you'll have your top and your bottom, which are your two invariant points. Okay? So this is kind of what the red zone is. It's between there and there. Between there and there, all points should be above the other graph. And from those points on, they will be below. Now, just that there is probably 80% of what you need to know to be able to graph any of these. Now, in all of these, we need to practice our domain or range. I think you can probably see that every time I ask people domain or range, I get a really ugly face, and then they struggle through it. So I got to make sure that that's not my fault. So I will try and make up any holes today. If you guys can't do domain and range, oh, it's going to be a horrible diploma for you, okay? So let's be uncomfortable now instead of on the big day. Okay, so for these, I'm going to ask people, first of all, I want the domain and range of y equals f of x. That's the original. Then I want the domain and range of the new ones, or the new one that I just made. See that red thing there? Okay? So let's start with Cody. Domain and range of the original. The original. Okay, and then of the square root. Greater or equal to 0. Good. Now, I'm going to teach you how to do the rest of these without using your graphing calculator, because as soon as you return the page, you're going to have to know how to do that. So in the next one, get the red zone, just between here and here. Now, this is a straight line, but it is more than a straight line. It is called an oblique straight line. An oblique straight line is anything that's at a slant. If it's straight up and down, or totally horizontal, so perpendicular or parallel to the x-axis, or parallel and perpendicular to the y, whatever you want to say, it is not called oblique. That is called a straight line. So oblique means slanted, a slanted line. Whenever you have a slanted line, you will have a concave down. So this part of the graph will be concave down. Now I'm going to kind of, I want to exaggerate it a bit because you need to be able to see it. Do you see that it is above the line? Because in the red zone, it'll be above the line. And then the rest of it's concave down going like this, okay? So this is supposed to be 1. But it will always be under anything that's out of the red zone. Okay, so obviously the red zone is not something you're going to ever see. It's something I've just kind of made up. But I'm going to talk about it often so you guys get, I guess, used to it. So you are thinking that way, okay? So I need domain, range, domain, and range. Sam? Original first.
Greater equal to, is that a -1?
Yep.
Y is greater equal to -1?
Nope.
Y.
These are the y values, okay? Where are you, little mouse? These are my y values.
What's the Y greater equal to 0?
Good. Okay, the next one. Yes? The red zone will always be between my two invariant points. It's always 1 and 0. Because the square root of 0 is 0, the square root of 1 is 1. There's no other. And an invariant when you're doing division is 1, right? 1 and negative 1 are the only invariant points when you do division. 0 and 1 are invariant when you're doing radicals, okay? So here's my graph. Red zone is always between 0 and 1, so I will draw those points there. The red zone, the graph must always be above the original, and out of the red zone you'll be below. And because this is a, what do I call this thing? An oblique straight line, it will be concave down. So you're going to get a graph that looks like this, okay? Okay, now for the fun part, Lorena. Please. Okay. See that. So, you know, these are all multiple choice questions, right? Okay, the next one. The red zone. Yep.
Just for the last group, is the invariant point 0 and 0 and 1 and 1?
No, no, only when y is, this is actually the red zone, when the y is 0 and the y is 1. Same with when we did invariance, and it was when y was negative 1 and 1. It has nothing to do with the x, because I'm taking the square root of f of x, which is the same thing as y. Right? Square root of f of x, same thing as y. Okay? Next one. Here is the first invariant point. The other one, I have no idea where it is, but I can tell you one thing. It should be above. Okay, Nancy? Nice. Did I do it right? Or did Nancy do it right? Some guys are looking at me weird. Like a booger or something? What's going on? Is this good? Jamie? Because in the red zone, it's not a line. It should be a curve, a bit of a curve, but anything above, anything in the red zone goes above. You won't see the other invariant point. It's way down there somewhere. Probably around Alyssa. Maybe, yeah, pretty close to her. Yep. Starts at the bottom, actually. Starts there and goes up. Are you talking the original or a new one? Oh, the original is going along. Looks like an asymptote or something like that. Yeah, that's true. But sorry. Yeah, that's a good point. If there's an asymptote, we could say, or this could just be greater than 0, right? That's another philosophical. I don't think we have time for it. Okay, next one. How would I draw this one? Okay, maybe even looking at the equation would help you. How do I take the square root of that? You can't. You can't take square root of negative stuff. So this would be x in the reals y would be less than or equal to negative 1. That's the original, and the other does not exist. Does not exist. Okay, so hopefully that domain and range do enough for... Now, I want you to go 2 pages, and I want you to go to here. Okay? Now, this is just kind of a review of what I taught you. Now, what is an oblique straight line? So it's not a diagonal, it is a slant. Okay? So, cannot be this or this. Okay? Anything in between. It is called an oblique straight line. Because actually when it's like this, taking the square root of it keeps it also straight. But you'll see that in the next page. Now do you see here? Here was the original. This was my original right here. And then I graphed it. Do you see that in the red zone? It is, there's the red zone, right? And do you see how that part of the graph is over, and it is concave down because it's an oblique straight line, okay? So anytime you see anything that is straight, it will be a concave down. And if it is curved already, it'll still stay in that curve. Okay, so if it's curving down anyway, it'll still stay down. But if it's straight, it definitely goes as a slant. And do you see everything that is out of here, it's not in the red zone, must be under the original graph. Okay, so if it's in the red zone, it must be above. Here you go, red zone, all of your belows, or between, sorry, anything in the red zone, your new graph should be above. Okay? So, here is everything that you need to know in a little nutshell. You've got, when f of x is less than 0, now f of x is considered a y, right? When y is less than 0, the square root of y does not exist. When it is 0, the square root is 0. And when it's 1, the square root will be 1. Those are called invariant points. Is Melanie here today? Okay. When it is between 0 and 1, it will lie above. When f of x is greater than 1, it will lie below. Okay, whenever you're trying to do the graph of a square root, pick simple numbers to square root. If you're going to square root the number 7, you're going to your calculator. 4 and 9 and 16, those are the ones that you want to do to help you get those points. Now remember, if you ever have an oblique straight line segment, the square root of that will be concave down on those intervals. Okay? So this stuff you have to know very well. Now this is a smaller unit, so I'm assuming 2 of these will be from the diploma. Okay? 2 questions. But 2 easy questions if you know your stuff. Okay, so we're going to use everything we've just learned to be able to graph this. Now obviously you can't put this into your calculator. In fact, it probably doesn't exist. Okay, but let's go through this one together, see if we can actually graph the square root of f of x. Okay, let's do it as a class. What should I do first? Do the red zone. Okay, so what I do is I want these points, right? Like that's, oops, yep. Anything between 0, like these are all invariant. Okay, and then just do your red zone all the way across. Now in your red zone, now what else do you know about the thing in the red zone. It's going to be above that. In what shape? Concave down, because it's straight lines. So we're going to do this in little compartments. So I got that one, this one, and this one. Is that making sense? Now, you see all this right here? This is above the red zone, correct? So my new graph will be above or below this? Below this. Now what I was talking about before, I want to take the square root of all these points. Because the square root of all these is this. Okay, the square root of all these, that's that. Trust me. The square root of these, though, let's do some thinking here, because we have this whole line is 4. What's the square root of 4? 2. So if you went down here, so I'm going to do this in blue now, okay? I'll call this the blue zone. So do you see how all of these points will be there? And this would actually, I don't think you need much imagination to see that's a straight line. So that's why that doesn't make a concave, because that's not an oblique. That is a parallel to the x-axis. Now, the other point that I would like to is I know I have to draw a line from here to here, right? What I would like, just for my own, well, you know, knowing that I'm going to get this point, sort of, this is 2. What is the square root of 2? That's the point I would put right here. What's the square root of 2? It's 2 because, look, 1, 2, 3, 4. So this is 2 here, right? So square root of 2 is? What is it? 1.4. So 1.4 would be about there. So that's what this is going to look like right there. And then let's just finish the rest of the graph. It's going to go here, go over there, and then it's going to kind of go like this. Actually, probably not that. You get the point, right? You're not going to get that wrong. What I will be looking for is obviously, do you have the red zone here? Is everything in the red above? Is everything in the blue below? And these are some valid points. If I just saw you went like this, you just draw this little concave thing all the way down. Now this one, obviously, I'm not going to get too picky about, but this one I would be very picky about because it is a... And that's your graph, okay? Your actual finished graph is... This always does it straight. Okay, oh, be nice. Okay, so that's your graph. Now, you need to know this entire chart to be able to do that, or all of these points, okay? Okay, Alex, what did I do wrong? Huh? That one? Oh, no, that's okay. If you got a question, ask a question. I don't care. Now, what was the domain and range of the original? And then we'll get domain and range of the... Sonia, domain and range of the original? Okay. The new domain and range? You're doing good. Very nice. Okay. Would you've got that question on a diploma, right? You have to understand that this graph actually starts and ends. The original didn't. The original went in infinite directions, right? But I can't have anything less than, so it starts and ends there, okay? So that's good. Now here is where I would know if you understood how to graph it by looking at this range. Now what would be the range, Sonia? No, not totally, because you got this part. Here, look at my y. So, yeah, nothing is less than this. I agree with you. But you're saying that all of these are on the graph. Less or equal to 2. Now, don't you see that I would be able to understand, or not understand, I'd be able to actually evaluate you just by this. Like, I don't need to look at this. This is on some scrap piece of paper you're throwing in the garbage, maybe. I might just have this picture and say, if you take the square root of that, what would be the new domain or range? And I think that you should not go from the question to here. I think you should do this and then go to the question and to the answer. Okay? Because if you can just look at this, and some of you will be able to go maybe from there to there if you can visualize this really well. Okay? So I'm promising you're making a picture somewhere, either on paper or in your head, to be able to get here. Now the next two are those kind of questions. I just want the new domain and range. That's it. Oh, that's not good. Hopefully, because that looks like I'm not recording. Oh, shoo. Okay, 42 minutes we've been talking already. Time flies when you're having fun, eh? Okay. Now, how on earth am I supposed to do the square root of just a picture? Now, is there any red zone? No, no red zone on this one. Okay. So, I mean, we always had a red zone, so I knew where to start. Now I can't even do that. So what do I do? Like, what would you do? You get this one on a test? All the y's. I would square root all the y's, right? All my x's will stay the same. So here you can see these are 9s, right? This is a 9 and this is a 9. I don't even care what the x is. I'll just go right below it. So all of these will come down to what? 3. Square root of 9. So that one's going there. This one would go here. And this one would go here. Okay? And I know that's 3 because, look at this. Okay? Now, where would this point go? What is it? So 1.7. Again, I don't have to be perfect. Let's say that goes there. That is 1.7, aka square root 3. Okay? And another good point, what's square root 6? 2.4, so it's a little, about right there, right? So this would look something like this, I think. Okay, and this is square root 3, right? Okay, now for the fun part. Brent, what's the domain of this? Second one. I don't care about the first one anymore. We're just going to go with the second one. Good. Range. Excellent. That is the answer. Now that is a good test question right there. It's quick, fast if you know what you're doing, and just like you would be guessing for sure if you didn't know how to do that one. Okay, one more. Now, does this one have a red zone? Yep. So I would get that, and again, you're going to have to use your imagination a little bit. I mean, there's 4, so let's say that's like 1, right? So here's my red zone. Okay, so that's that. So Maybe I'm going to draw those there. Now what do I know about those points? Or those parts of the graph? They should be above, right? Now, here's the question. Is that above? No, because people might go, well, I don't know what side. So this is where you would be above. And again, I'm exaggerating it horribly there because I need you to see it, right? And then here's another above. And here's another above. And again, this graph's going to look not very fluid because of this. Yep. No, but if it does have a concave that way, you continue it that way. Right? So, like this, yeah, this, I can see what you're saying. I mean, it's going to, yeah, don't get too caught up on that. It's almost a straight line. I'm going to treat it as that. Okay, now, let's just deal with this section. What point is going to be the highest that this gets to here? 2, okay? Now, can anybody actually, I should ask before we start, anything kind of different about this graph? It starts and ends, doesn't it? It doesn't have arrows. So be careful on domain and range if they would ask you the original on that one. But it does maybe have a bit of a bearing on our. Okay, so I finished this part of the graph. What should I do with this? Just forget about it. Because anything below, so you got below, red, and then blue zone, okay? So maybe I'll do this in blue so I can be consistent. Right, the one we just did was entirely blue zone, the A. So B. Now, what else do I have for this thing? Like I can't graph this, but I can graph this part yet, right? What would that be? What's the highest I'm going here? 3. So I've got a point like 3 here, okay? And it has a bearing. Oops, see, this looks horrible, but anyway. Okay, so that's negative 3, 3. This would be 6, 2, right? Now, to finish this off, we're going to do some domain and range. Vanessa? You just got the hardest one of the day. Don't worry about it. Okay, so before you go on, oh, I should have made this blue. But do you see? I need you to tell me first the domain of this part of the graph. Is it just less than this? Because what do you know about this? This stops here, so this stops here. So these are the x's we're talking about for this part of the graph. Describe these x's for me. What is it greater or equal to? Maybe look at mine here. This point here, negative 3, right? So it's got to be, okay? And now you got to describe this part to me. So this has an or statement. It breaks up. Okay, so the question is, could you get this one in diploma? Yes? What's wrong? Okay. Do you see this from here to here? This is negative 2, 0, and that's negative 3, 3. So those, I'm just looking at my x's, right? So it's not connected from here to here. This is a whole separate graph. So Vanessa, I haven't forgot about you. Okay. Range. It's another tough one. Nice. Good job. Okay? So a pretty simple question to put on a test. Like it's simple to make that question. And you see, I just have to ask domain or range, and I got ABCD. That's it. Right? I think you should graph it. I think you should try to look at all the points and then go to the graph. Yep. That's a very good question. Do you see that when I have this y interval, it actually is still included in this one? Right? Whereas this x interval, does it include this one? So if I talk about from here to here, see if I had this graph, I don't know, let's just say it went like this over top of it, and I, say this is negative 4 and this was like 10, I'd say x is between negative 4 and 10 of all of it, right? Because that red one, those other two are under that umbrella. Whereas when I describe this part of the graph, I'm saying you can use just these y values. Well, look, these ones are already in there. Okay? Yes?
Why did you do square root of x below the...
You can't take the square root of negative numbers. Square root of negative f's. These are all negative y's, right? Okay. So we're doing 1 to 12. Okay, I'm actually going to go right back to that homework because I didn't scroll down on it. So give me a second. I just got to, for those people that are on band trip and all that stuff.